future. I really can't overstate that. It is incredible to see this many people in a room all excited to talk about GraphQL. My name is Dan Schafer. I'm a software engineer at Facebook. I've been at Facebook at this point for about 7 years. From 2010 until 2012, I worked on the newsfeed team. And then at the very start of 2012, I was working at that point on a new newsfeed API, just with the server side, wasn't thinking about clients at all. And through a combination of fortune and just more fortune, ran into Lee Byron and ran into Nick Schrock, and started working on something that eventually emerged as GraphQL. So for the talk today, I wanted to talk about the evolution of GraphQL clients over the last 5 years, because that's something that it's really been fascinating for me to watch. And as I was trying to assemble the talk, I realized it was almost impossible to talk about how our clients had evolved without also talking about how GraphQL itself had evolved. And as I was trying to summarize this, I realized we've already done that on a blog post about GraphQL. This is an excerpt from, it was actually in May before we released the spec. And I just want to read it because it's so captured what I was trying to say. It's product-centric. GraphQL is unapologetically driven by the requirements of views and the front-end engineers that write them. We start with their way of thinking and requirements and build the language and runtime necessary to enable that. And that, to me, just captured what we were trying to do and really informed how GraphQL evolved really through, and it's kind of an oversimplification, the 3 phases of its history. There was that initial prototype from what, the original super graph diff that has been mentioned so many times, until we shipped the initial iOS app that was using GraphQL. The sort of evolutionary phase that happened inside of Facebook before we released the spec in July of 2015, and then obviously the evolution that's happened in the open source world. And so I wanted to sort of go through each of these phases and talk about how the clients evolved, and then see sort of how that affected what we were doing with really GraphQL itself. And it really starts with this initial prototype. And I'm going to blatantly steal from a talk I gave last year at React Europe, where I showed these 3 core principles of how our GraphQL server worked. We said, these are the principles on how to build it out. We think in terms of graphs, not endpoints. We want to have a single source of truth. We want to have a thin API layer. And these were principles that we had arrived at and that we therefore recommended might be valuable for building servers. But I realized, how did we arrive at these? These didn't just sort of emerge from the primordial void as yes, this is the right way to do things. The way we arrived at them was really informed by what we were trying to do in that initial prototype of GraphQL. Because if we flash back to the pre-GraphQL, pre-GQL, pre-Supergraph times of January 2012, this is what our prototype iOS client looked like. We were trying to rewrite our iOS client to be a native app as opposed to being a wrapper around an HTML5 view. And we were using an API that we had called FQL. And FQL was trying to solve almost similar problems to GraphQL, the issue of you wanted the client to have control over what data was going to get back from the server. And so it created this SQL-like syntax for fetching data. And it was awkward to use. This is not a sort of made for this slide exaggeration of how awkward it is to use. This is, if anything, a massive simplification of what a real FQL query would have looked like. I believe the one for our camera app that we had at the time did 7 or 8 left joins on all of these tables, and because you're trying to fetch this nested data, and this is what you had to do. And so unsurprisingly, our clients wanted something better. And so that was the problem that we were faced with at the time when trying to develop this initial prototype. And a massive simplification of our stack at the time, we had this business logic and storage layer. And then FQL ended up being this sort of wrapper on top of it. And so now we're into February of 2012. We have this extremely awkward proto-GraphQL syntax. And we're trying to build this initial prototype. And this is what the diagram looks like. And it's probably unsurprising what we ended up doing. This is over the course of a few weeks. We just filled in that box. We said, okay, let's
take that layer that used to be FQL that wrapped the business logic and storage and instead install a different layer, a different way of fetching the data. But what did this mean for that first GraphQL server? Well, we're building for this prototype iOS client. We have no idea how it's going to evolve over the next months until we ship it, so we can't just build a dedicated endpoint that gives them exactly what they need. Really, the only thing we had to work with was the conceptual graph, because we knew that existed on the server, so we thought in terms of graphs, not endpoints. We were also trying to build this in the course of weeks. So we couldn't reinvent the wheel. We couldn't come up with a great new idea for authorization or authentication or batching or caching. We had to rely on what we already had in that single source of truth. And finally, this was a crazy, hack, not quite hackathon, but like weeks-long hack of an idea that might not even work. We wanted to make it as thin as possible. We weren't trying to do more work than was necessary, so we ended up with a thin API layer. And so these principles, they've evolved to be principles of how our server functions, but these were the constraints that original client placed on us. Even from the very beginning, the idea of how we were going to build a GraphQL server was, what does the client need from us? What can we build to make the client's life better? And that's what we did. OK, so now we're on to this evolution phase. It's August of 2012. We have shipped the original iOS app. It's version 5.0. It's the first one using GraphQL. And since then, our apps have continued to evolve, and we've continued to need to scale them. And so really, as we encountered different places where our apps needed to scale, GraphQL needed to evolve with it. And so the first thing that we needed to scale was the models themselves. And so I want to quickly walk through what it would be like in the, that original 5.0. We're writing 5.1 now, or whatever it was, and we're trying to change what it does. We're trying to build a new feature. So let's look at a trivial example. This is a query that's going to fetch my name and my profile picture. And let's say at this time, I want to change it to fetch my name, my nickname, and my profile picture. This is easy enough. This is an easy change to make. You can type it into graphical. You can see it's going to fetch nickname. We're in good shape. But what do we have to do on the client to make this work? Well, at that time, we were using core data on our iOS app in order to store all of our models. And core data is this library given to us by Apple that gives you sort of an ORM-like facade on top of your data. And it ostensibly takes care of storage for you and consistency for it. It's just like, here's a model. It has all the data on it. It just sort of works like an ORM. And so if we're going to start fetching nickname, and we're going to want to start accessing it and rendering it, we're going to need to add it to core data. So let's really quickly walk through the process of adding nickname to core data. Remember, adding it to GraphQL was that one-line change. So core data is given to us by Apple. It's all configured in Xcode. So the very first thing we're going to do is open Xcode. All right, cool. It's actually a lot slower than that, but I didn't want to waste too much time. Now we have this lovely dialog. And so it's a very simple process. We're going to click, you can see one, we're going to click on our data model. And then it's not highlighted, but there's a list of entities. You're going to click on the entity that you want to change. And then if you go a little bit more, there's attributes, and attribute shows all the properties. And you're going to type in the name of the attribute. That would be nickname. Don't misspell it, don't typo it. It won't give you an error message. That's a perfectly valid thing in Xcode. It just won't work. And then you have to re-enter the type. And you're probably thinking, well, we already know the type in GraphQL. Why are we re-entering it? It's because it's good for you. And then after we do all of that, we get this lovely, completely opaque, unreadable XML file, which we now commit to the repository. So ostensibly, we're trying to make client developers' lives easier, right? And client developers were very clear about what they thought of this process. And so we needed to solve this. We needed to scale the app to more users. And so the solution that we had was we started generating code, which we inevitably refer to as CodeGen now. And I want to be clear, because CodeGen has trade-offs. It is not always the right decision. It's not even clear that if we were doing this again, we would use it, or we would use it quite as ubiquitously as we did. But at that time, it was solving a real problem that we had. Because in this query, like if you give me this query and you give me introspection, I know everything about the model at this point. I know what properties a user has. I know what type they are. And so I don't need to go through Xcode at all. I don't need to open up this GUI in order to do this. I can just generate this mess of an XML file for you, and you commit that, and now instead of opening a GUI, you've run a single CodeGen script, and you're done. This is great. Client developers are happy. But this had consequences, because we've just added a build step, right? What I just described, that script, that's a build step. And so that means that our GraphQL cannot be completely dynamic. It has to be static, because we need an input to this build script. And so this led us to start using static queries, which we put in .graphql files. And client developers like this too. They're like, that's fine, I can use static queries. But this is what we used to have them do. They used to use basically a query building API in Objective-C in order to assemble their queries. And one nice thing that they had here is if they wanted to reuse functionality, well, now we're reusing functionality in code. We have ways of doing that. We can use a function. And they would factor out their code into functions, as reasonable engineers will do, and reuse it like that. And now we're saying, well, use static queries. Like, okay, that's great. I have this static query. I want to reuse this profile picture field across a bunch of different queries. Well, how do we do this in static files? And this is an interesting crowd to ask that question to, because probably most people are saying, why wouldn't you just use a fragment? Like, that's exactly what fragments were made for. Yes, that is exactly what fragments were made for. They did not exist in the language until we encountered this problem. Fragments came into GraphQL because we were doing code gen, right? We needed code gen, which means we needed static queries, which means we needed a way in a static query to reuse functionality, and that's what created fragments for us. They feel super obvious. If you've seen GraphQL since we open source, it's like, oh yeah, of course you have this primitive for like reusing fields. That's something you would want. Those were added because the client needed it. The client encountered a case where they could not build something without it. And when we initially built fragments, this is a query, and you can imagine typing this into graphical. Well, you couldn't type it into graphical. The server didn't know anything about fragments in that initial version. Instead, that client build step that we would do would just defragment the query. And it would send this to the server, and the server could be completely oblivious to fragments. And I actually went and I pulled the original diffs where they were added to the client and the server, and then I pulled the timestamps, and it was months where we were iterating on fragments on the client, and the server was like, I don't know, just send me a query. That's what I know how to understand. And then I also pulled the timestamps, June of 2013. So we're actually fairly far into the sort of evolution phase of GraphQL before the server even has any idea that fragments are a thing. And this was a pattern that we saw ourselves doing over and over again. When we were trying to add a feature to GraphQL, we wanted to see, the reason we wanted to add it is because the client needed it. And it's why I titled this talk Client-Driven Development. Because I feel like when I think about that phrase in GraphQL, it really has multiple meanings. The standard meaning is, oh, the client chooses the fields, the client is in charge of the response. But I think it's even more than that. The client controlled the evolution of the language itself. All right, we've scaled our models. Now we're trying to scale our views. And the first thing that we ran into when we were trying to scale our views was we needed to scale our models again. Because these core data models were great. It's the standard way of doing things. But they had massive issues. So the biggest problem, honestly, was if you were using one of these core data models and you're trying to render it, you're probably on the UI thread. And most of the time, that would work fine. And then occasionally you'd be like, oh, I want to access this field. And core data is like, I actually didn't have that in memory, but it's fine. I'm just going to go to the disk and come back. Like, I was on my render thread, and you just went to disk. You're immediately going to have just a terrible scroll performance. The app's not going to feel fun to use. The other thing we ran into is just the general nature of core data started scaling super linearly with the number of types in the app. And if you've ever seen a stat about how many types we have in Facebook schema, you really don't want super linear, not something fun. So we wanted to move away from core data. We're thinking we need to evolve how our models work. And meanwhile, as we're realizing we need to change how our models worked, we also were radically rethinking how we did views. We were starting to use, in JavaScript, React. And this style of programming, this idea of being a better way to build views with this one-way data flow, with props and state, with reactive views, was taking off. And we've eventually developed on iOS something called Component Kit, which can pretty accurately be described as a React for iOS written in Objective-C. And on Android, we've developed and recently open sourced Litho, which, for lack of a better phrase, is React for Android written in Java. So our models are changing. We know that we don't want to be using core data anymore. And our views are changing. We know that we want to be moving towards the sort of React Component Kit Litho style. How do we connect? How do we deal with the flow of data into reactive components? And fortunately, the people working on React at Facebook had developed a pattern called Flux. And so if you've used Redux or any other JavaScript library that ends in ux, you're probably familiar with the pattern, or you've at least used it. And if you've ever seen a talk or anything on Flux, you've probably seen this diagram. I think you're required by law to show it in any presentation on Flux. But this diagram is actually there for a reason other than because I'm doing a slide on Flux. This really was how we were starting to think about our native stacks. And let's start filling in. We can fill in some of the boxes already with how our native stack is going to work. That first action box on the far left, that's how we're going to populate our initial data. Well, it's a GraphQL query. That's how we're going to populate our initial data. Then the dispatcher, that's the thing that gets the GraphQL query and understands it. That's going to be some sort of GraphQL engine that's probably able to parse things. It might do consistency. The store, well, the store is interesting because we knew we wanted that to vend immutable models. Immutable models were nice because we're going to avoid any sort of threading issues. It's also going to give us a lot of possibilities for improving rendering because our rendering is going to be reactive views. And reactive views can do clever things when you have immutable models. All right, so we're almost done, but we're missing one piece. What's that last action, that thing that sort of hooks around and goes back to the dispatcher? Well, I said that we were using immutable models. We can't just like randomly be tweaking fields on that. And so in Flux, the idea is if you want to change something, you send this action back to the dispatcher saying this is what's changed, and it will then updates through the system. So in the GraphQL namespace, that's GraphQL mutations. And it really is not an exaggeration to say that this idea of the Flux architecture is how we came up and how we designed GraphQL mutations. And it answers a number of questions that we get about the design of GraphQL mutations. One of them that people often ask, why are they top-level mutations? Why is there sort of this namespace mutation where they all live? Why would user not have a name field and also like a rename mutation? We could have done that. There's like a perfectly valid way to build out mutations in that style. Why are mutations actions? Sort of this top-level list of things you can do and not sort of based around like a create or an update or a delete pattern. And the answer always comes back to this diagram. Our clients were moving towards this diagram. We needed something that would fill in this action box, and GraphQL mutations is what emerged. I was actually talking with Lee earlier, and he joked, we may have misnamed GraphQL mutations. We maybe should have named it GraphQL actions, because it really was designed to fill in this box and give an answer in our application of Flux to GraphQL for how you did writes. So the idea of mutations is now here, and then we just implemented it, and we went home. It was great. No. Mutations was a huge question mark at the time, so huge that I changed the font size on the question mark. Because this is 2013, GraphQL is a query language. It's like right there, it's the queue. Like, does it have any business writing data? When we were initially working on GraphQL mutations, we would occasionally refer to it as GraphML for mutation language, just because that's how foreign the entire concept of writes was to GraphQL at the time. So how do we know if this is actually something we want to build? Well, we did client-driven development. Our clients wanted them. We weren't sure if it was a good idea to add to GraphQL at the time, so we shimmed them on the client. And this is sort of the way that our clients used to work if you were like trying to like a page. You would send a request to some arbitrary write endpoint and get back a response, often this incredibly useful true payload. And then you'd be like, I actually wanted to fetch some data with that, thank you. And so you'd send a GraphQL query and get a response back. And if you were particularly clever, instead of doing 2 round trips, you would use our batch API and say, OK, send the post, and then in a dependent query, fetch the data, and then you get all the data back. Well, if this is how we were doing at the time, we could effectively give you this GraphQL mutation facade. We could say, all right, you write a GraphQL mutation. Under the hood, we're actually going to send to the server this post request and in a batch request the GraphQL query. And then when we get the response back, we'll reshape it into the mutation response and hand that to you. And this critically allowed us to incrementally add value to the client. Batching logic was kind of hard to maintain. That wasn't code that people liked to write. It was super imperative. And so you would be writing less code, and you would potentially get better performance. Client developers were pretty pleased. They had to write this super annoying DSL that described how to map a GraphQL mutation into this REST endpoint and also the query. I'm going to move off this slide because I'm really ashamed of it. But instead, you would be able to write this, which should just look like a GraphQL mutation, that you would write that. And then we would auto-generate this code for you, which takes care of all of the nonsense. This is all the crazy, like add the batching, make sure the dependency is there, and it just gives you this nice GraphQL mutation-like facade. And we built this on iOS and Android, and people started using it. And clients liked it, and clients said, yes, this mutation API, this is something we would want to use. And so we ran the same trick, and we added it to the server. This time, it was close to 6 months. Where we were just using this on the client, proving to ourselves that, yes, this was something really valuable, this was worth adding on the server, and then once we did so, we created it. Also notable, we're, 2 years into the evolution now, or close to it, before mutations ever hit the server. So what's this third scaling issue? We've scaled our models, we've scaled our views, now we're trying to scale the app. And our app at this point looks in a very broad architecture diagram like this. We were using GraphQL for our models, and we're using React for our views. And when you think about those 2 technologies, maybe one word is coming to mind. They're declarative. And declarative is good. The product developers say what they want. They're not saying how to do it. It means that infrastructure developers can do interesting things underneath it. It's easier to maintain. And I would agree that we were declarative-ish. Because we'd evolved these apps over time. And yeah, our models were fetched declaratively using GraphQL, and yeah, our views were rendered declaratively using something like React or ComponentKit or Litho, but we were still gluing together the app as a whole with imperative code. And so we really were missing a piece in between, and sort of at this phase in development is when Relay really first started to come into the picture. Because it was trying to rethink the app from first principles and say, how declarative can we make the whole app? Now that we know that we're going to have a declarative renderer and declarative data fetching, what does that mean as the whole shape of things? And I'm going to steal from a previous slide again, because it's great reading other people's blog posts. And this is Greg Hurl. He had this post either yesterday or the day before on the making of Relay Modern. And it described one of the original principles of Relay, actually, before it was even named Relay. That was one of the big ideas was query collocation. The notion that you should be able to specify your data requirements for each view component inside the view itself, and that the framework should transparently handle aggregation and efficient fetching. Collocation, right? If you've used Relay, if you've used Apollo client, you're probably like, yeah, of course you're going to collocate. And this is one of those crazy things that once you've seen it, you cannot unsee it. And until someone's pointed out, until someone's shown it to you, is completely opaque. It took us, what, 2-3 years before the idea of collocation even came about. And it was just a massive shift in how we thought about our clients. But even more so, it was a massive shift in how we thought about GraphQL. Because remember, the original idea around fragments was they're just for code reuse. There's no meaning to them. They're the equivalent of those helper functions we used to have. They're glorified macros. Well, not anymore. Now fragments are more than that. Fragments now, at this point, are a core primitive in how we think about GraphQL. They have intrinsic meaning on their own. They used to just sort of be a helper for queries. And at this point, honestly, queries are almost like the way that you combine fragments. We'd almost inverted the importance, inverted the dependencies. And once you start to think of fragments as being more than basically glorified includes and glorified defines, new ideas emerge. And for one of those ideas, I have to go back to models. Because remember, when we were originally designing our models, we were still using core data. We'd since moved away from it, but the core data way of thinking was an ORM. It would say, oh, so you have a user type in the system and a page type in the system and a group type. Well, those are your 3 types of models, user and page and group. And so if we had this particular type in the GraphQL DSL, it's a very straightforward user, then our corresponding type, I'm using flow here because it fits on the slide, would look like this. Right? You're going to have a user type in your client because you have a user type on your server. But this doesn't really work, though. Even this thing I described here, I say that name is a string, and I'm not saying it's nullable. Because if we look at that name on the type, it's got string exclamation point, it's not nullable. I can't really guarantee that on the client side. Because I might have issued this query. I might have said, just get me my profile picture URL. Well, if I hand you a user after issuing this query, name's going to be null. I didn't fetch it. It's not going to be there. And so this type isn't even right. I actually, if I wanted to model this as a user, I would have to say everything is always potentially nullable because you just might not have fetched it. We can't guarantee that. That's annoying. It actually gets worse than that. What if we had these 2 queries? Now we're using aliases. And on the timeline, we want to display your name, but in your bookmarks, we want to display your nickname for some reason. And we both alias them to display your name. Well, what's our user type going to look like on the client side? It'll look like that. Is this, I mean, it works. Does it even make sense? If I hand you a user and you access display name, do you have any idea what's going to come out of that data model? It gets worse than that. What happens when I do this? On my profile pic query, I alias profile pic URI to be the pic. On my cover photo query, cover photo is an object for whatever reason, and I alias that to be pic. What's the type of pic now on user? I mean, I guess it's going to be any. Like, we just have to use the escape valve. We have no idea because it depends on where you got it. And in fact, in the situation I just described, we just disallowed those queries on a global level. We would literally look at every query and say, somebody already picked that alias somewhere in the application. You can't use it. And type models just didn't match how we thought about data. It wasn't how our clients wanted to think about things. It's how the server wanted to think about things because it was exposing the schema. It's how core data wanted to think about things. But we thought that we could do something better. And the key thing that let us do something better was thinking about fragments as a core primitive. Because once you have fragments and you're thinking about these as a top-level thing, well, if I look at this fragment and I think, what data is going to get returned, I can tell you exactly what data is going to get returned. That's the entire point of GraphQL. It's the entire point of a fragment. This user with pic, it's going to return a type that has a profile picture field that's going to return, in this case, a nullable profile picture. Profile picture is going to have one field on it, and it's a URI. We can use the fragments to define our types. And this concept is, we call them fragment models. They're just much more compelling if you've used sort of the masked models in Relay or on iOS clients, Android clients. A lot of the native clients that are being developed are all designed around fragment models. It's really, at least in my mind, a best practice for clients now. If you're developing models based on GraphQL, to use the fragments as the source of truth for what data you're going to have, because fragments are the source of truth about what data you're going to have. So, as we finish up, let's stop talking about history and start talking about the future, because there's no actual end dot there. It's going to keep going. And one thing I want to talk about is one more feature that clients wanted during the evolution phase. Client developers would come to us and say, OK, I want to fetch nickname, but for whatever reason, nickname's really expensive to fetch on the server. And I'm only showing it in one particular A/B test, where we're showing the nickname on the timeline. Can I do that? Only fetch it if I'm in that test group. And the answer for a while was no. And then we're like, yeah, that seems really valuable. We want you to be able to do that. We'll add a feature for that. And so we hacked it in. We literally put a parameter on every single field in the entire schema named if. That took a Boolean. And if you passed in false, that would always return null. And it would, in particular, would short circuit actually running the resolver, so you didn't do any of the server-side work. And this worked great. It solved the problem. But it never quite felt right to us. And so as we were leading up to the open source release, we started to rethink this and say, is there something we can do that's better than this? And this is actually where directives came from. This is sort of how they got into GraphQL. We were looking for a cleaner way of doing this. But directives ended up being more than that, because they weren't just a way that you could annotate the query that the server could understand. It was a way you could annotate the query so that the client could also understand. And so in my mind, directives offer just an amazing amount of power. And in particular, they're sort of the core primitive that allow for client-driven development at this point. And that it lets us experiment. It's a formalization of sort of the ad hoc, adding fragments, adding mutations process I described earlier, where we let the needs of the client drive things forward. And so as I think about the future of GraphQL and where it's going to be, I think back to 5 years ago when we were working on it, and there's no way that we could have imagined fragments or mutations or fragment models or subscriptions. There's no way we could have imagined that someday there would be a conference in Berlin with 300 people all here to talk about GraphQL. So thinking forward to the next 5 years, it's no way to tell what's going to happen. But if I had to guess, or if I had to hope, I hope that it continues to be driven by the clients, and that that's what shapes the future of GraphQL. Thank you.
Thank you very much.